we're going to be talking about manipulative in math that I absolutely love called Algebra Tiles. The question is, why would we want to use Algebra Tiles? Sometimes we think math and algebra is confusing enough. Why would we want to add something else in there? Algebra can be really confusing for our students and something that's really abstract. So giving them something, an actual manipulative, like Algebra Tiles, which kind of look like these, we're going to go through them in just a sec, but giving them something hands-on to work with for something that's so abstract can be so helpful. So for example, if we have this function, f of x equals x squared minus 2x minus 3. And we want our students to find the factors of this. Some students can do this if they know kind of the procedure, but other students might need something hands-on that they can actually see so they can conceptualize something like this. Or, simpler still, what if we had this equation, or this isn't even an equation, it's an expression, but x squared plus 2x squared plus 3 plus 4x, and we want our students to simplify this. And we want them to combine like terms, that sort of thing, but it's hard for them to see which terms they should combine and what they would equal. Algebra Tiles is a great way to give students a conceptual idea of what they are actually doing when they are simplifying equations like this or finding factors. Alright, so these are what Algebra Tiles look like. They come in a box like that, probably other things too. And I'm just going to go through the basics real quick of what these are. So, this is representative of an x. These little units over here are representative of 1, so they're 1 unit in length. These big tiles represent x squared. So, and the reason for this is we can see the x squared here. So, if we have that x squared, it's the length is an x and the width is an x. It's exactly the right length there. So x times x equals x squared. So it's using sort of an area model there. Each algebra tile has two sides, a red side and a colored side. The colored side represents positive and the other side represents negative. So if we're doing a problem like this, x squared plus 2x squared plus 3 plus 4x, we can represent this like this. X squared, because that's the x squared term, plus 2x plus 2x squared. Remember, these are x squared terms, so if we want 2x squared, we just need 2 of them, plus 3. 1, 2, 3, plus 4x. 1, 2, 3, 4x. So now it's kind of easier to see what we need to do to simplify. So x squared plus 2x squared, that's just going to be 1, 2, 3x squared. 2x plus 4x is going to be 6x, which we can see here. And then we've got our 3 over here. So this expression simplifies to 3x squared plus 6x plus 3. And using algebra tiles is a really great way to see, oh, we can't combine, because like a lot of times students will want to combine x squareds with the x's, but we can't do that because they're not the same shape. So algebra tiles are a great way to do something like that. Algebra tiles are good though for more than just combining like terms of polynomials and stuff. We can also multiply binomials. A binomial is just something with two terms just like that. So x minus 2, x plus 1. And we want to multiply these together. Well, something in the traditional way of teaching, we would just teach our kids to distribute, which we totally can do that. We want them to get there. But algebra tiles can be a great way to just kind of reinforce that. So the way we would do this with algebra tiles is we're going to model this first binomial up top. So we've got x minus 2. Okay, well, remember that a 1 unit, if we turn it out the other way, to make it red, it's negative. So we've got x minus 2, and then x plus 1 on this side. And we're going to use the area model here, so that's how we set it up. And we want to use the area model to compute this. So we know an x times an x. We can see that that is going to be equal to x squared. That makes sense, because the area is filled up there. Then, let's see here, if we have an x times a red 1, that's going to give us a red x. Same thing with this one. Down here, we're going to have an x times a yellow 1, which is going to give us a positive x. And then we're going to have a positive 1 times a negative 1, giving us a negative 1. And same thing over here. So now we can easily see that the area, we just have to count it up, is x squared plus x minus 2x minus 2. Well, a plus x and a minus x cancel. These cancel out. They're a zero pair. And then we're just left with x squared minus x minus 2. And we would get that if we multiplied it out. The great thing about this is we can also work backwards. So if we say we have this area in the middle here, x squared minus x minus 2, represented there, and I want my students to factor. Well, factoring is just the opposite of multiplying binomials. We want to find the things that are going to go on the sides here versus having the sides and finding the middle. So to do that, we just have to look and see what would create this. Well, on this side, I know I need an x up here to create that area. Oops, not a negative x. I want a positive x. And on the other side, I need an x too. Up here, I see that these are negative, so these have to be negative. And then on this side, this is negative, so this is negative, but this is positive. So this means that this is going to need to be positive. And quickly I can see that I can find my factors, x minus 2, x plus 1, x minus 2, x plus 1, just simply like that. So we can do factoring, multiplying binomials, and just adding like terms. There's tons that we can do with that. Thanks for tuning in. I hope you learned something new today about